All right, so today's lesson, we're going to be going over section 1.4 and 2.2. So we're going to start with 1.4. So 1.4 is on reasoning and proof. We're not going to go too far in depth into this, but you already have a couple of problems on this. So just to brush over really quickly, these are several properties of equality that we can use. So a lot of these you guys already know, but now we're just putting a name to them. So addition property is saying that if A equals B, then A plus C equals B plus C. So let's say if 5 equals 5, that's my A and my B, and I add some C, let's say C is 2. 5 plus 2 is obviously equal to 5 plus 2, right? Subtraction property is saying if A and B are equal, then A minus C and B minus C is also correct. These are all the rules that you guys are using when you're solving. Multiplication property, if A and B are equal, then A times C equals B times C. Division property, again, if A and B are equal and C does not equal 0, because that would make it undefined, then those would also be equal. Reflexive property is A equals A. So a lot of times we'll see it's the same thing, right? It's 5 equals 5, 2 equals 2. Symmetric property is A equals B, then B equals A. A lot of times we'll see that whenever we're proving, like let's say we solved a problem and we had a number first. Well, usually in math from now on, they want you to write your X first. So a lot of times you'll use symmetric property for that. Transitive property is popular as well. Basically, if A equals B and B equals C, eliminate the B in both of these, and A would equal C. That's the common thing between the two of them. And last one is substitution property. If A equals B, then B can be substituted for any A in the expression. So I'm not really looking for book definitions. We're going to see how this applies when we're doing problems. So my first question here is 14 equals 3x minus 4. So I'm going to go ahead and start solving this question. Well, the first thing that we would do when we're solving is we would add 4 to both sides, right? So when I'm adding 4 to both sides, that property is going to be addition property of equality. So now 18 equals 3x. The next thing I would need to do to get to my next step is obviously divide by 3 on both sides. So that is called division property of equality. And I would get 6 equals x. And I would just got done telling you guys that probably the newest property that you would have is that you don't want to write your equality like with the number in front. We want to go ahead and flip that and state that x equals 6. And the property used for that, which is probably the one you'll have to memorize the most, is symmetry property of equality. And the exact way that I wrote this is exactly how you can write your solutions as well. We're not going too deep into this, but it just gives you an idea of how proofs look. Let's try another one. And I know that these examples don't really line up, so don't worry about it. We're skipping through some of the stuff from my regular slides. So use a postulate or a theorem to find the value of x in each figure. So we have a line segment here. We know that this piece is x plus 2, this piece is 3x minus 8, and the entire line is 5x minus 12. So what we would do for this problem is we would be using what's called the segment addition postulate. So these are line segments. So in this scenario, it says use a postulate or a theorem to find it. We don't need to write all the little explanations. We just need to say what postulate we're using. So this is called segment addition postulate. Now, there's a lot of postulates in this section, but I'm only going over the ones that you really need to know. So this one is popular. So basically what segment addition postulate tells us is that if I take segment RS and I add that to ST, then I'm going to get the full line, RT. Again, kind of like that theorem where you eliminate the common factor. They both have an S in common. And now I'm just going to simply plug in. So RS is x plus 2. ST is 3x minus 8. And RT is 5x minus 12. I'm not going to worry about writing out all the rest. I really just want you to focus on understanding which postulate you're using. That's also how this type of question is going to be quizzed for you. So I'm going to combine like terms. Remember, we're not using a calculator. You got to get really good on your math, on your algebra skills, okay? I like to put the x first, so I'm going to subtract 4x on both sides. And then I'm going to add 12 to both sides. So again, I'm going to get 6 equals x. And by the theorem of symmetry, we have x equals 6. I'm going to go back and reread the question and make sure that that's what they were asking for. And sure enough, it's asking me to find the value of x. So that is the solution. For my next example here, I'm going to go ahead. This one comes with a figure. So let me draw it really quickly. This is R, S, T. And then there's an extra little gray in here. This is x plus 25. And this angle is 5x plus 10. So use a postulate or a theorem to find the value of x in each figure. So this is the same question as the last one. So for this one, instead of it being a segment addition postulate, this is not a segment, this is an angle. So we are going to be using angle addition postulate. And basically the angles that I'm going to be using is I'm going to, let's say this first angle here in blue, pretend like that overlapped, is angle RSP. And I'm going to add that to the bottom portion here, which is going to be angle PST. And when I put that together, again, the common items are going to go away. You notice they both have that. It would give me the overall RST. And now I'm simply just going to plug in. So RSP is going to be x plus 25. PST is going to be 5x plus 10. Now, I'm not putting the Celsius on there. I'll just add it on at the very end. And that's going to equal angle RST. And I was given that angle RST is right over here. Angle RST is 15x minus 10. So I'm going to combine like terms. On the left-hand side, x plus 5x is 6x. 25 plus 10 is 35. I'm going to drop down my right-hand side. And now I'm going to start to bring my x's together. I like to do that first. So I'm going to subtract 6 on both sides. Add 10 on both sides. You guys are going to hear me call this step right here, the plus 10s and the minus 6x. Those are what I consider baby steps. In this class, I would like for you to try and not have to write those. So you force yourself to go from here to here without writing the plus 10 on both sides. The reason being is because if you were to do that in a calculus problem, you would run out of time. Because remember, everything is timed. I talked to you about that yesterday. And you want to try to eliminate those baby steps. So for example, do you know how to go from here to what x equals? Well, I know that I would be dividing by 9 on both sides, so I would get x equals 5. So if you can do it without having to write the divided by 9, that's what I'm trying to suggest here. I reread the question. It was asking for x. So work on trying to eliminate those baby steps, okay? And last one is linear pair theorem is also extremely popular and important to know. And basically that means that when you have a linear pair, that the angles are supplementary. Now, supplementary angles are two angles or angles that add up to 180. They create a straight line here. So you'll see lots of examples of this. Let's say, I'm just going to use this definition here. Let's say angle 3 is 125 degrees and angle 4 is 5x plus 10. Okay, if that's the case, then I'm going to go ahead and add angle 4 and angle 3 using this postulate here. And when I add those together, I should get 180 degrees because it's going to tell me that it's supplementary, or it's going to show me a straight line. And then in order to solve this, I'm just going to combine like terms. I'm going to subtract by 135 on both sides, trying to eliminate those baby steps. Then I would divide by 5 on both sides, try to do it in your head, and I would get x equals 9. So if the question asked me to solve for x, then that would be my solution. Okay, I just wanted to mention that theorem. So the main thing that I want you to remember is angle addition postulate, segment addition postulate. Just know a little bit of how to basically use those properties to show equality, because that's what you've been doing in algebra, and then linear pair theorem. Okay, make sure you guys continue to put your questions on the Collaborate form, and I